Alright, in this video we're going to talk about how to graph a circle on an XY coordinate plane. So we've talked a lot about circles, theorems to do with circles, parts of circles. Now let's talk about how do you actually get them onto a graph. So first we're going to talk about the equation of a circle with the center at the origin. So first of all, the origin is the point 0, 0. So it's just at the very, very center of like an XY graph. And in this equation, we're going to let r, lowercase r, represent the radius. So if you wanted to like get a calculator and tell that calculator to graph a circle with the center at the origin and radius r, what you would do is you would type in x squared plus y squared is equal to r squared. So the r is going to tell the calculator basically how big or how small to make that circle based on what the radius is. Now we can also use this equation to graph things by hand, which is what we'll be doing most frequently in this unit. So first thing we're going to do before we start graphing is just looking at the equation, we're going to determine the radius and the center. So the center is 0, 0. We already kind of talked about that. That equation is centered at the origin. So I'm going to go ahead and put a dot where the center is. Then this 36, that's equal to r squared. So I'm going to go ahead and kind of set up like a mini equation over here. The 36 is equal to r squared. So I want to solve for r and figure out what the radius is. So I'm going to take the square root of both sides of this to figure out that 6 is equal to r. So my radius is 6. Now how do I use that radius to actually draw my circle? Here's what I'm going to do. I'm going to start at my center and I'm going to go out 6 points in every direction that I can. So I'm going to go out 6 units to the right, 6 units to the left, 6 units up, 6 units down. Okay. Now notice that I'm not going to go 6 units like diagonally because it's quite impossible for me to figure out exactly where 6 units would fall if I don't have the units marked out like I do when I go left, right, up, and down. Then all I have to do is connect my dots. And I'm not usually very good at this, so let's see how good the circle turns out. I'm just connecting these 4 dots that I created. That turned out okay, I guess. So now I have my center at the origin, and then that circle with the radius of 6. Let's go ahead and do another example. So in this next equation, or in this next example, we're going to be graphing x squared plus y squared equals 13. So my center is going to be 0, 0. So let's just start by putting that point on my graph. Then I need to figure out what the radius is. So remember that 13 is going to equal my r squared. Lots of people make the mistake of thinking that the 13 is the radius, but the 13 is not the radius, it's the radius squared. So then I'm going to take the square root of both sides. So r is equal to the square root of 13. Now that's great. Knowing this r is equal to the square root of 13 is awesome, except for I have no idea how big the square root of 13 is. So what I'm going to do is I'm going to use my calculator to change that into a decimal. And that is about 3.6. So when I write my radius, I'm going to put both answers, my exact answer of the square root of 13 and my decimal or approximate answer of 3.6. Now one of the reasons that I really like having that decimal answer is that when I get to actually drawing this circle on my graph, I need the decimal. For me, I need the decimal to know how far left and right I need to go for my center. So I'm going to start at the center and I'm going to go over about 3.6, put a dot. Go up about 3.6, left about 3.6, and then down about 3.6. Then I just got to connect the dots of those 4 points that I plotted. It's not going to look beautiful, but it's going to be something. So there's my circle that is centered at the origin that has a radius of the square root of 13. So let's do some practice going the other way. Let's say I want to write an equation of a circle that's centered at 0, 0 and has a radius of 11. So I'm going to start with my base equation, x squared plus y squared is equal to r squared. The only thing I really need to change is the radius. So x squared plus y squared is equal to 11 squared. And then we generally figure out what 11 squared is. It's 121. And we'll write that into our equation instead. So x squared plus y squared equals 121. That would be the equation of a circle centered at the origin with a radius of 11. Now these circles that we've been looking at in the last 3 examples are all centered at the origin, or are centered at 0, 0. What happens if I want to change the center of the circle? Like, let's say I want the circle to be up in the top right corner of my graph or something. That means I need to change the center of my circle. So right here, we're going to talk about the equation of a circle that has a center at the points h, k. So h is any x value, k is any y value. So that equation looks like this. X minus h squared plus y minus k squared is equal to r squared. And this equation is going to allow us to kind of switch around the center of the circle and move the circle around on our graph. So I'm going to zoom out so that we can see both the equation that we just wrote down as well as the equations that we're working with. So in these equations and these examples, we are going to determine the center and the radius of the circle and then use that information to graph it. So in example A, I have x minus 2 squared plus y minus 1 squared is equal to 9. So these two numbers, the 2 and the 1, those are going to be what give us the center. And here's one of the trickiest parts, or one of the most important things to remember as you're finding your center. It's always the opposite sign of what's inside your parentheses. So I have like a minus 2 right there, which means that my center is going to be at a positive 2. I have a minus 1, so my center is going to be at a positive 1. And then my radius is the square root of 9, which is just going to be 3. And if you are still having a hard time finding the radius, you can always set up the equation r squared equals 9, take the square root of both sides, and get that r is equal to 3. So now let's go ahead and plot these points. First thing I'm going to do is plot the center, so 2, 1. And then I'm going to go out 3 in every direction. So this is important that you start at the center and go out 3. So I'm going to go 1, 2, 3, have a point there. 3 in the other direction lands me over here. If I go 3 up, it's going to land me clear up here, and then 3 down right here. So remember that as you're counting the radius distance, you're counting it from the center. If the center happens to be at the origin, great. But if the center is somewhere random on your coordinate plane, you need to make sure that you are counting out from that center. So let's go ahead and connect those dots into one of my really sloppy but good enough circles. All right, let's go ahead and work on the next one. So let's find the center of this circle first. So I have the x value of my circle is going to be a negative 3, because there's a positive 3 in the parentheses. And it's going to be, be a positive 5 because I have a minus 5 in the parentheses. Then to find my radius, r squared is equal to 1. Take the square root of both sides. The square root of 1 is just 1. So my radius is 1. So let's go ahead and draw my center on here. So negative 3, 5. That puts my circle center right there. Then I just need to go up 1, or out 1 rather, in every direction. So I'm going to have this little kind of bullseye looking thing. That one was bad. Up here in the top left of my graph. It's important that as you're drawing your circles, you do draw a point, like 4 points to be part of your circle. If you just do 1 or 2, you're not going to get a very accurate circle. So do draw a point up 1, down 1, left 1, and right 1 from your center. All right, I'm going to let you guys try C and D on your own, and then come back and check your answer. All right, this is what you should have gotten for both of these examples. One thing you'll notice in example C is that my radius ended up being a decimal approximation because my square root didn't simplify to a whole number. Another thing you'll notice that's interesting about D is that there wasn't a number inside the parentheses with x. It was kind of just by itself. Whenever that's the case, your center is going to be at 0. In this case, it was 0, 2. So that's why I'm getting the center coordinates for that point. So now let's do a couple examples where we are given the center and the radius, and we are just going to write the equations. So in this first one, I'm going to have the equation of x minus 2. So remember that the x value of your center always goes with the x coordinate, or the x parenthesis, and the signs always switch. So x minus 2 squared plus y minus 5 squared is equal to 7 squared, which is 49. Same thing over here. We're going to have an x minus 3 squared plus a y plus 1 squared. So keep in mind, again, I'm changing the signs of these coordinates as I put them inside the parentheses. And that's equal to the square root of 13 squared. Now, if you remember, the square root of 13 squared, the square root and the square root will cancel out. So I'm actually just going to be left with an x minus 3 squared plus a y plus 1 squared is equal to 13. Let's go ahead and jump down actually to example D. So I'm going to have an x plus 5 squared. And then I'm going to go ahead and write this in as y minus 0 squared. And we'll talk about what we can do with that next. And then I have a 2 square roots of 3 squared. Now I'm going to leave the x plus 5 by itself. But I'm going to change this y minus 0 squared. Because y minus 0 squared is just y squared. So whenever you have like a minus 0, you can just rewrite it as a y or an x squared. Then I need to simplify my radius. So I have 2 square roots of 3 squared. So I'm going to distribute the square in. And I'm going to get 2 squared times the square root of 3 squared. So let's do one more step of simplifying here. 2 squared is 4. Square root of 3 squared is going to cancel out. So I just have a 4 times 3, which is equal to 12. So this is going to be my final answer here. And you do want to simplify this down so that you get kind of the simplest looking equation that you can at the end. All right, I'm going to hit pause and let you guys work through these other 3 examples and then come back and check your answers. All right, hopefully you got these 3 answers for these examples. One thing I wanted to talk about really fast is this very last example, F, because your radius is 1 over 2. And so when you take 1/2 and you square it, I just wanted to remind you guys what you do with that. You would square the top of your fraction and you would square the bottom of your fraction. So 1 squared is 1, 2 squared is 4. So that's where I got that 1/4 in my equation. Okay, let's do a couple more examples where we are going to identify the radius in the center based on the picture and then write the equation. So first I'm going to plot my center. So you've got to find the very middle of your circle to figure out where your center is. In this case, the center is -2, 4. Then to figure out what your radius is, you basically need to figure out how far over did you go to get to the outside of your circle. And it looks like we went over 2, which means our radius is 2. Once we have the center and the radius, we can just plug those into our equation. To get the equation of that circle. All right, let's go ahead and do the next one. So first thing we got to do is find the center of this circle. If finding the center is hard for you, guess where you think it is, and then just make sure that if you go like up and out in every direction, you're going the same amount. Okay, so our center here, let's see, is we went over 1, 2, 3. So 3, 1. Over 3, up 1. And then my radius, I would figure out by telling me how far do I go from my center to the outside of my circle, and that is 3. And when I give you an equation like this or a picture like this, I'm going to give you a radius that's a whole number. Just because you're trying to figure out if it's 3.4 or 3.5 or 3.1, that's just kind of crazy. So just expect a whole number radius if I'm giving you a picture like this. Then I can use that information to write the equation of my circle. Oops, not a plus 9. Equals 9. Remember, I'm getting that 9 because I'm squaring the radius value. So that is your basics of how to use, find, and graph using the equation of a circle.